Actually, first I would like to thank Peter and Johannes for their kind invitation, as well as the other PhD students. I'm really happy to be here in Innsbruck. It's my first time here in this city. It's, I mean, I saw a part of the old city. It's quite amazing. It's a pity that I couldn't see the mountain, but next time I think the weather will be much better. So basically, what I will speak today about some ongoing research I'm making about computation and nihilism. I would say that the subtitle of this lecture could have been that one: arguing up to the last confines of logics, the consequences of the current computational reconstruction of the world. By using this expression, computational reconstruction of the world, obviously I refer to Karl Knapp's book, Der logische Aufbau der Welt. And I assume that most of you, especially because it's a very famous book in German philosophy, I assume that most of you know that book much better than myself. But in any case, I'm really interested in that. I mean, the fact that in the recent years, we really experience what I call the computational turn. Some other people like Mario Carpo speak about the digital turn. I won't argue today about the difference between these two expressions, but I definitely prefer computational rather than digital. Anyway, so I choose to speak about theory today, but just to give you a very, very quick overview about the current design research, because I cannot completely separate both activities. I will show you a couple of things. As it was said, I'm writing. I used to write. I mean, every year, or something like 2 essays per year, something like that. Quite many years ago already, some were published, and especially that one not on computational architecture, on optimization, which I wrote in 2003, actually. I insist on this one, on the fact that it was written in 2003, because in these essays, I wanted to address the issue of optimization and what it could mean in the contemporary architecture culture, because optimization is probably one of the most used words in the contemporary discourse in architecture. Many people are using this word, having different things in mind, and I was interested in the meaning of optimization, not only in terms of engineering, but also more generally regarding all its aspects in the industrial culture, in the social environment, etc., etc. In fact, one of the very first building we could consider purely as a pure result of optimization strategies, at least according to Charles Jenks, because Charles Jenks is taking this building as an example. It's the Northwich Park Hospital, in which, in fact, the structure is only designed according to the distribution of the loads, actually, and there's no predetermined geometrical patterns. So long time ago, in 2003, I wanted, with my partners at EZCT, Jelle Feringer and Felix Agid, actually, we really wanted to address this issue of optimization, but it came slightly after the essay. In fact, it was more like a proof of concept. So we went quite deep into optimization, making use of genetic algorithm in architecture in order to produce this case study. It's just a chair, but at some point a chair is one of the most iconic objects in architecture, even if it's not architecture but design. This is why we choose this, because my hypothesis was the following. I mean, if you really want to show an evolution in the history of design, you need to take the most elemental and the most traditional object. So either it is an house or is it a chair. I mean, I think for me it really made sense to think that way. So we produced this chair, which is now part of the Frac Centre and Centre Pompidou collection. But on that, starting from that, and obviously it brought some sort of pixelized aesthetic. So it's a 2003 and 2004 project. But starting from that, I started to ask myself, okay, how could we move from this to the large scale? Because in fact, this voxelized aesthetic is fine, but if you want to move it to the large scale, you will just replicate this kind of architecture we saw in the 60s or 70s, in which you have a big voxel, which is nothing more than an habitation unit, you know. I mean, it's a room, basically, which is very much what the Japanese architects were doing, and more recently, Winimas and MVRDV were using this strategy as well. But I was not interested in that. I was interested in this in terms of construction. So I started to look at the connectivity that could exist actually between cells and say, okay, in fact, these voxels, they are not just let's say, discrete elements. They can also create some sort of continuity between them if you use this in a smart way. So the challenge was really about the scaling of this voxel-based approach, and it led to a project which I called the Universal House project, and you will see later why I'm using this idea of universalism, actually. So it gave birth to this, and to this very, let's say, rough prototype made of fiber reinforced concrete. So in fact, you assemble the cells in the way you want, and you obtain different, let's say, different concrete, let's say, lattices. So we worked for that in partnership with the Lafarge team, and ultimately we wanted to achieve this kind of component, but based on a voxelized strategy. So you will ask, okay, why doing this? Why are you looking for this kind of light frame, I mean lightweight structure? I'm not really an ecologist. Let's say, or either I am one, or I am not an ecologist, or I am a really radical one, because in fact, I would love to have all the wild animals everywhere around, etc., etc. So, in fact, I don't like parks. I don't like gardens. I don't like all the flowers that are selected. I just like nature. I mean, I would just love to be surrounded by, yeah, wilderness, you know, I mean, just wild animals and trees and things like that. I never go in parks. I have never visited any parks in Paris. I'm living there for 20 years. I find this really boring, actually. So this is why it's difficult, but if I am an ecologist, it might be a radical ecology proponent. So in any case, if you look at these numbers, at these figures, it's quite shocking. And during this lecture, we will approximately make use of 400,000 tons of cement, which is 120 tons per second. So in fact, if in the 60s, making this kind of architecture was a matter of fanciness, it was really about style. At the moment, we don't have any choice. We cannot be in a stylistic approach of architecture anymore. Because, I mean, when you build that, you have to keep in mind that in another part of the world, it might definitely kill some animals, at least, and more often some people. I mean, there's no innocence anymore. I mean, the age of innocence is definitely over, let's say. And I think that architects should think really seriously about that. And fanciness might be criminal at some point. So we have no choice in trying to make things lighter. And it's not a matter of aesthetics. It's just a matter of survival at some point. Even if I don't agree also with this kind of apocalyptic scenario, but I cannot go into the detail about that now. So anyway, in the past, many people tried to build a lightweight structure. Gaudi did that, but I don't like arches. I mean, it's like that. I'm not such a naturalist. I much prefer this kind of work by Shukov, for example, or this kind of space frame invented by Alexander Graham Bell, who, by the way, is only the inventor of the telephone. So this guy is really fascinating. He gave birth to two of the major inventions of 20th century, actually. So in any case, this is what I'm interested in. But I want to do that not in steel, but with new materials, with concrete, for example. If I take a look at such a building, for example, I'm much more interested in what is under the skin. It's a very Massin approach of architecture at some point. It's very much about construction rather than about the way the architecture look like at the end. So I'm interested in that, but not in steel. I'm basically interested in this in a more advanced way. This is a Raj Revel building in India. I think it's amazingly elegant. And this is some of our work, actually. So basically, I believe that the real challenge in architecture in terms of construction is to make the intrinsic geometrical and topological complexity associated with optimizations buildable. For example, if you look at this genetic algorithm-based evolution strategy, first it's 2D, it's not really three-dimensional, but in any case, if you look at this, if you look at the mold, it's very, very classical, and then it starts to be super messy, and it's really craftsmanship, actually. You can't do nothing out of that. Even if the end result is quite beautiful, in terms of process, I'm not really happy with this. So we started to investigate the use of 3D printed sand casting techniques slightly before it was, I mean, sand printing was made, let's say, very famous by Benjamin Dillenberger and Michael Hansmeier, and we were interested again not in that in terms of let's say skin or pattern, but more in terms of construction. So we use this for lost molded approaches, actually, like this, with all the pieces numbered, and we produced what we believed to be so far probably the first lightweight three-dimensional high-performance concrete lattice, actually. It's made of ductile, which is a Lafarge product. So it's a high-performance concrete, which is also fiber reinforced. So there's metallic fibers into it. So we are lucky enough that this piece was later bought by the Centre Pompidou. So this is it. We made a couple of projects about that. This was a competition for Osaka, actually, revisiting the gigantic megastructure of the Japanese architecture, but making this super light as a super light 1 kilometer long space frame, which wouldn't be obviously regular. So at the office with some student interns and young engineers like Romain Duballet here, we are also developing interesting strategies to produce lattices in an automated way, actually. And finally, recently, because I wanted to make sure that we could manufacture these things, and I was not happy with the existing technologies on the market, available on the market, we decided to create a company which is called X3, which would be entirely dedicated to the making of such complex geometries. So we bought the robots and everything, actually. And we try to work in a rigorous way with our partners, especially in the robotic and material industry, for example, Lafarge Holcim, but also in the software industry, because we are now supported by Dassault Systèmes, actually. So what you can see on the right here is, so it's a 3D printed element in concrete. And as you can see, the quality of the concrete is so great that you cannot even identify the layering when you cut the part. So you have to put a mark in order to make sure that you remember in which direction, it was cut. So we made a couple of analyses about that. And we obtained some very interesting results. So these are the results. This was done by Clément Gosselin, which was my student last year, under my supervision, and with Jean-Aimé Chou as well, and also with the help of Romain Duballet, Philippe Roux, and Nadja Godilier. So this is not printed with standard concrete, but with high performance concrete. For the one of you who are, let's say, at ease with these numbers, just for your information, it's a 110 or 120 megapascal compression. Yeah, I mean, it can add. It can stand for 120 MPa in compression, which makes it obviously a super high performance concrete. So this was the pieces presented in a show, and this gives you an idea of the scale of them. We are also printing clay, and we use the clay printing as a strategy to create molds. Ecological molds, because then you can just remove actually the clay. I don't have to go deep into that because you can just look at the video on the website. You just remove the clay, which is not cooked, with water, and after removing the clay, you obtain this kind of component in concrete. And you can reuse and reuse and reuse again the clay. So I believe it's kind of an interesting approach, and obviously we keep investigating those things. So let's jump to the theory, and just forgive me in advance if I will be a bit fast about that. But in fact, I believe that, yeah, I mean, even when I try, I cannot separate practice and theory. I believe that architecture is about both, even if sometimes it's very difficult to, let's say, to deal with both aspects of that, actually. So, in fact, recently, I haven't been so satisfied about the theory produced in the architecture, in the architecture, actually, in the discipline of architecture. In fact, let me first explain one word. When I use the word computationalism, I'm not speaking about what happens in the cognitive science. It has nothing to do with cognitive science. I just wanted to make this clear. Because what happens in cognitive science when they speak about computationalism is in fact very much metaphysical. I mean, it's just an hypothesis, and we don't know very much about that. It's just an analogy between the human mind, I mean the brain, and the information processing system, which in fact is a computer. So I'm not very much into that. But in fact, these analogies are quite old, and this is precisely why I'm not that much interested into this. I mean, from let's say Descartes, 1637 until today, we always are in this kind of analogy between the machine and the human body. Even in the discipline of architecture, if you look at Diller and Scofidio's Slow House project, for example, this is very clear. And if you look at the work of Bernard Cache and Patrick Bosset, then you start to see a different path, which is taken with an analogy which is less visible. But still, this is very much vitalist as an approach, and I'm also not very much interested into that. So in any case, I'm interested in understanding a bit more what happens with the advent of all these technologies. So Greg Lynn opened the path about that. And with Bernard Cache, I spoke, for example, about the non-standard product, and it was made very famous with the exhibition Architecture Non-Standard in Paris. But as far as I know, the first guy who spoke about the non-standardization is really Marshall McLuhan. He wrote in 1969, actually, when electronically controlled devices are perfected, it will be almost as simple and cheap to obtain 1 million different objects as to make 1 million identical ones. So, according to me, was a real pioneer about this idea, this concept of non-standardization. Even if, again, people like Greg Lynn developed this. But if you look at the discourse of Greg or Bernard Cache, etc., again, it's a bit too vitalist. These are images of the end of 19th century, actually, or not even the end, but the middle of 19th century with Granville. And you see this kind of metaphysical interpretation of the fact that everything is just an evolution of everything else. And this kind of drawing was later used, much later, I mean 60 years later, used by Darcy Thompson. And in fact, it relates to the belief that was very common at that time in mathematics, in the fact that a law, I mean a mathematical law, or let's say even more than that, a law of nature, is a constant relation between the phenomenon of today and that of tomorrow. In a word, it is a differential equation. And this is, I mean, the differential equation is what is represented here by Darcy Thompson. But by the way, he was not a true mathematician, and there's no differential equation in that. It's just a style of differential equation graphics, but it's not true in a sense. But in any case, this concept of differentiation, differentiality, etc., was used constantly in the recent architecture discourse. I'm more interested in terms of history of recent architecture in what Nicolas Negroponte developed in the architecture machine or what was also developed by John Fraser in an evolutionary architecture. As well, I believe that Cassos was really crucial in the understanding of what is happening today. And the more we move, the more we see how his prediction were regress at some point. So, and finally you find Novak and Karl Schuh. Both are also much closer to a kind of metaphysics of architecture, or at least using the words of Karl Schuh, a metaphysics of computation. Now on another side, you have an analysis of globalization with all the aspects associated with the demographic evolution, actually, which brings us back to Le Corbusier. This is a very Kollesian attitude. MVRDV brought, I believe, another layer on top of the discourse of Rem Koolhaas by addressing the issue of datascaping. And I believe it's a fundamental difference because data are really key today. But if you go back, in fact, you see that some underestimated architects like Konstantinos Doxiadis were already using this because, for example, this project for the planification of the UK actually was done by Doxiadis in '65, and it was already using a computer which was a Univac 1107 produced by the RAND Corporation, and it was one of the most powerful computers in the world, actually. It was one among the 30 most powerful computing machines in the world, which in fact is very significant. Just imagine today that, for example, I don't know, OMA or the added architects or any big offices like that would have one of the 30 most powerful computing environments existing in the world. It would be something, let's say, probably similar to some of the very big banks like Deutsche Bank or UBS or whatever. It would be really awesome and something extremely radical. This is why I'm also very much interested in Doxiadis, because it's unbelievable how you can underestimate the importance of such an architect and theoretician. In '67, he gave an interesting series of lectures, which were, by the way, called Fortran, actually, which is a nice name for an architectural lecture. So anyway, he had this kind of global attitude, speaking about the future climatic condition. So just keep in mind that this drawing was produced in 1960. And we are nowadays speaking about the global warming. So if we speak about who is an avant-garde architect, I mean, obviously Doxiadis was an avant-garde architect. He also addressed the issue of civilization at large by proposing a new interpretation of Toynbee, and also he developed the issue of migration, which is also a very crucial issue of today, actually. We all know these things. I mean, these are images I took myself, actually taking the boats from Greece to Italy. It was 8 years ago, with a lot of Pakistanis migrants all around trying to enter the boats and the trucks, actually. It was in Patras, actually. So anyway, the situation we are living in is that one. But when we look at some discourse, what we see is this, actually, the generic city by Rem, and more recently the fundamentals exhibition in Venice, which is about floor, wall, ceiling, roof. I mean, I can't understand that. because I had the feeling that what was so amazingly important in architecture were science, capitalism, energy, ideology, geopolitics, and even pollutions. I didn't have the feeling that stairs were such a big deal in the history of architecture. So it makes me really depressed when I see this kind of very, let's say, old-fashioned kind of discourse entering again the discipline of architecture. It's really like reactivating the dead body of Durand. Actually, everything is static. But at some point, it was also the problem of modernism, while in fact we know that nothing is static, everything evolves. We have committed already hundreds or even thousands and thousands of mistakes, and we start to do it again, actually. Which for me, I mean, it's like if Rem didn't have read this book from Peter Blake. Yeah, I don't get it anyway. So if I look at this propaganda map of the British Empire, actually, inviting people to love the British Empire, we know that it doesn't work. I mean, not all people like empires. And in fact, on a global scale, we have the feeling, and this is what I will explain, we have the feeling that we are entering this kind of nihilistic time in the Western history. I would say again, because also at the end of the 19th century, this feeling of entering a nihilist period already appeared, and you can easily take, I mean, consider this by reading Nietzsche or Dostoevsky, but also many other people actually. But in any case, I consider this as a fundamental law, in the fact that in social life nothing stays rigid or final and nothing will ever be. So I don't want to define architecture in terms of fundamentals, like it was, let's say, even if it's a bit fancy to do it at the moment. So Brandy, who probably read Gramsci actually, produced this beautiful structure and liquefaction drawing in 1668. So we live in this world, which was well explained already. If we look now at another aspect, which is the issue of language, which is related to the computers, actually, because we have this aspect of language. When we work with a computer, we work with programming language, etc. We have, I mean, some people have the feeling that the language of the computer is replacing the natural language, and that it could help us in order to escape, again, this kind of nihilistic feeling. In fact, it's not so simple. You will see that language is something, I mean, more complex than that. And in computer simulation at the moment, there's no true language of computer simulation. But anyway, so the deep nature of technology. When we look at technology, we have two kind of discourses, actually. We have this one. New technologies are great. They allow us to design and build such or such new things. Yeah, I mean, in a sense, it's a tautology, because if they wouldn't allow us to do anything new, we wouldn't call them new technology. So when we listen to this kind of discourse, or when we read about that, we don't learn anything about technology. On the contrary, when you look at radical anti-technologist discourses, for example, from Kaczynski, Theodor Kaczynski, I don't know if you know that guy, but he wrote what I consider one of the main books in social theory, which is Industrial Society and Its Future. Is more well known under another name, which is Unabomber, because he was a terrorist in the US, and the FBI actually took something like 15 years to catch him. But he was a genius in mathematics. Then he stopped doing mathematics. He resigned from one of the most prestigious universities in the US regarding mathematics, actually. And he started to live alone, a bit like Thoreau, actually, and to write theory. So what he says is that industrial society cannot be reformed because modern technology is a unified system in which all parts are dependent on one another. You cannot get rid of the bad parts of technology and retain only the good parts. Take modern medicines, for example. Progress in medical science depends on progress in chemistry, physics, biology, computer science, etc. Advanced medical treatments require extensive high-tech equipment that can be made available only by a technologically progressive, economically rich society. Clearly, you can't have much progress in medicine without the world technological system and everything that goes with it. So this kind of deep structure of technology is also very, let's say, puzzling. It really creates anxiety because we have the feeling that we cannot act anymore on anything. Therefore, we have this feeling of or this temptation in going into nihilism again. And when we look at that, we don't know what to do, actually. We have the feeling that nothing can be done. And this makes this situation very, very difficult in terms of architectural theory. Because for many architects, they have the feeling that they can, let's say, have reformist approaches, and I absolutely don't believe that we can reform any kind of system at the moment, actually. It has gone too far, and the roots of that are really deep. As soon as the second, let's say the 1950, the automatic factory, for example, in terms of work, was already well set, conceptually speaking. All the elements of an automatic factory were present. And this is what we know today with all the sensors which are mounted onto robots. Machines without men were already a reality. And in fact, the deep relationship between this automation and the wish of the white collars to destroy any form of revolt or strikes by the blue collar were already present. So this idea of autonomy, in fact, is not. It's not new. It's deep. We all believe that it will, let's say, save the world. By the way, this is a Mustang, a Ford Mustang, and it's a drawing which was also presented by Charles Jenks in his book Architecture 2000, which he published in 1971. He was quite good in predicting the digital turn, in a sense, because approximately at the same date, we really started to see, especially in the university laboratories in the US, project for automated autonomous vehicles, actually. By the way, much before the Google car. So the project of autonomy, it's something which is conceptually treated, for example, by Pierre Vittorio already in the discipline of architecture, but according to me, we are speaking about a fundamentally different concept of autonomy. And I would love, in the work of Pierre Vittorio already, for example, to see some sort of almost Hegelian dialectics between these two different concepts of autonomy. Because if you look only on one side of the coins, you just forget almost everything about the world as it is at the moment, and you go into a super idealistic architectural discourse, which I believe is a great mistake for architecture. You need to consider the issue of productivity, which is behind this, and capitalism as well. The issue of labors, what happens with the machines, with the computer in the business world, and what is the true reality of the work, especially, for example, in the finance industry. If you go back in the literature about that, you will read, for example, in 1934 by Thomas Watson, who was the founder of IBM, actually, a very, very interesting series of essays and hypotheses about the future of the finance industry. Not especially the finance industry, but the fact that any kind of work and any kind of company will be replaced by another layer, which is purely financial at some point. And it doesn't matter what you are producing. What matters is only the number of computers you have at some point. This is based on the work by Bachelier, who invented financial mathematics at the very beginning of the 20th century. By the way, he was a student of Poincaré. He made a PhD with Poincaré, and it gave birth to what we now know as derivatives product. So all this world is what we are living in. Some people say, yeah, maybe we can change this. Architecture can, maybe we can produce some sort of alternative architecture. Let's take the example of the market. Maybe we should regulate the market. This is easy politics, in a sense, because objectively speaking, it just doesn't work. If you look at all the conditions for this kind of discourses, you cannot find any solution. Let's take the example of the finance. In the finance, there is something which is called the Perso paradox, and here it is what it means actually. The observation of safety. I mean, if you want to regulate the market, so the observation of safety creates risk, where large numbers of market participants takes very similar risk-reducing safe positions, and thereby, via the near homogeneity of their position, this greatly increases the overall systemic risk, actually. And in fact, if you look at these things, you have many different approaches. So some people, for example, at Princeton University, they are trying to find alternative politics. And I don't believe, again, in this kind of, in the possibility of alternative politics. Because the way technology has entered the world and also the finance industry is too deep, actually. You even have this kind of research trying to find the relationship between the geomagnetic storms and the stock market. I mean, when you think of it, it's just insane, actually. I mean, you can make use of the geography in order to make more money. So this map, for example, it's a map which shows the optimal location of the stock exchange that should be created on Earth. And then you see that some of them are in the middle of nowhere in the ocean, actually, which is also something quite fascinating. So in any case, we have entered that. A world in which you have on one side mathematics and on another side, let's say, politics, which is useless, which cannot control anything, and which gives you the power that you can do something, which in fact is absolutely not true. So we enter this situation. It's a kind of reversal of Marx quote, actually. In Marx, logics is the money of the mind, and I would say that today computation is the mind of the money. And we enter this kind of unlimited capitalism, actually. The more I mean, the deeper we go into the matter, the more powerful the computer are, the more powerful and the deeper capitalism is as well. It's really this kind of almost fundamental law of capitalism, actually. So, in fact, some people in the 60s, like Paul Virilio, Jean Baudrillard, they started to understand this a bit more. They went back to more abstract notions of let's say, computers, but they treated this on a cultural level. So what I'm, let's say, doing in my work at the moment is this. I mean, trying to understand these roots. For most of them, they are really, let's say, going from, I mean, spanning from 1650 until the end of the 19th century, with the very first computer. I mean, it's not a computer, this is a Pascaline, created by Pascal, who was also very influential in this movement, which is the movement of Port-Royal in France. They wrote about la logique de Port-Royal, actually. And then also with Leibniz, who, by the way, invented the binary notation you see on the right. Then you have all these histories of machine at the end of the 19th century in UK, and also a movement which was moving in parallel about logics in Germany with Frege, and also in Italy with Giuseppe Peano. So by looking at that, what is interesting is that we start to enter the conceptual roots actually of a situation we are only experiencing now on a social level. Obviously, the social situation at the time of Giuseppe Peano or at the time of, Frege or Hilbert was fundamentally different from the one we are experiencing today. But conceptually speaking, the roots of this abstract world that we are experiencing today is there. This is why I'm referring to this. So now let me make a short conclusion about nihilism, and you will see why I'm let's say converging toward this idea of nihilism actually. Because on one side, so let me go quite quickly about that, but as you can see, everything can be reduced to numbers, actually. Machines, mechanism, everything. You can translate everything in algebra. And let me read this quotation. Look at this, for example. About the origin and the limits of the correspondence between algebra and geometry, actually, which was written by Cournot. It's a very important book. And later on, actually, Poincaré said that it seems that there is nothing in mathematics which cannot be reduced to algebra. So if you add these conceptual roots from the 19th century, actually, the more mathematical, the more philosophical roots from the 17th and 18th century, and then the technical and technological progress from the 20th century, we are moving into a, let's say, a context that we can only consider as computational. So this is why, for me, in such a context, which I consider purely computational, we need some theory for that. And computationalism is the name I choose to use, actually, in order to describe this shift. So if you look at standard rationalism, you have these disciplines, actually. And this is very much what we were using until the year 60s. In the year 60s, in the 20th century, obviously, it was quite obvious to still speak about biology, chemistry, linguistics, etc., etc. Even new words, for example, semiotics, started to appear. Regarding that, but I'm interested in computationalism as something which has deep consequences on every aspect of the social life. This is why I say that computationalism is also a social theory. It has nothing to do with parametricism or anything like that. It's not about style, it's not about shape. By the way, it has no shape and it has no style. It can have any shape and any style. It's something which has to deal on a global scale with this kind of liquid and highly distributed forms of urbanization, and on a global scale, on a local scale, which has to deal with the house and with, let's say, living units which are stuffed with computers. So, it's what I believe is fundamental is to link these two aspects and to make an hypothesis about that. I mean, in which world we are really entering with the advent of the computer? What does it mean actually? Can we still consider ourselves in the framework of a humanistic? In a humanistic framework, which most of all is defined by a common language. If you read some philosophers, like Frank Varenne, which I believe is one of the very, very talented young French philosopher. I consider him as the next Bruno Latour, actually. I think he's excessively brilliant. Here is what he's saying. I mean, all his work is dedicated to the concept of computer simulation. And he says simulation is more and more using multiple mathematical formalisms that coexist in a non-mathematical way. Which are not reducible to a same and unique axiomatic. Simulation is neither a discourse nor a language because of the heterogeneity of its conceptual tools. Simulation is giving birth to a history of an ecosystem filled with hundreds of composite and heteroclite mathematical beings. Simulation depends on and reveals an intrinsic polyformalism. So this is what he's writing. On another aspect, you have the issue of speed, almost with a kind of messianic and religious tones of propaganda. This comes from a book which is published by Facebook and which is distributed to all its employees. So, I mean, it could have been written by any religious movement. The quick shall inherit the earth. I mean, this is really like some sort of messianic tones at some point. So if you look at all the people who try to address the evolution of the society recently, and most of all during the 20th century, I find only very, very few of them, in a sense, tried or managed to catch the most radical aspect of what we are experiencing today. Among them, I believe that futurism, the international situationist, and at some point suprematism and surrealism really managed to catch what we are living, our current situation. You know the book, The Cultural Logic of Late Capitalism. At some point, I would say today that what is important to catch is the computational logic of the nascent capitalism, which is only starting. Surrealist artists ask this question: is surrealism the communism of genius? I don't know about surrealism, probably, but computation at some point is, because it allows all of us to produce things that were absolutely non-possible before. It creates this kind of suprematist pattern in the civilization, actually. And we clearly see this evolution, according to me, when we look at the work of some of the artists, like Russian supremacists, who are all, or even this pattern of robots, which are assembled as swarms, actually. We see this kind of grid, and grid computing is also now becoming something absolutely major. But on another level, we also have this phenomenon, actually. So on one side, we have computers everywhere, and on another side, we have this, actually, which I mean, these almost two contradictory ways of addressing our situation is very puzzling, according to me. And because nobody is really capable of understanding how those things can, let's say, coexist together, this creates the feeling, the very deep feeling of anxiety I was speaking about, and this kind of nihilistic attitude. But if you look at this, then you say, okay, but why this nihilistic attitude can happen? Do we have objective argument about that? And if you read the futurist artist, the futurist manifesto, then you can find some objective argument, or what I call objective hypothesis. And according to me, it's first very beautiful, but most of all, it perfectly fits to what we are experiencing now at the beginning of the 21st century. So this is the first sentence of the manifesto of the Futurism Manifesto, which was published in Le Figaro, actually. We had stayed up all night, my friends and I, under hanging mosque lamps with domes of filigreed brass, domes starred like our spirits, shining like them with the present radiance of electric arts. For hours we had trampled our atavistic ennui into rich oriental rugs, arguing up to the last confines of logic and blackening many reams of paper with our frenzied scribbling. What's important for me is this, arguing up to the last confine of logics. And what are the consequences of this? I mean, what happens if we argue to the last confine of logics? What happens if we really ask about computation, what it means, what it deeply means? And then we find this, written for example, by Ernst Mach, the famous Austrian philosopher. Strange as it may seem, the power of mathematics rests on its evasion of all unnecessary thoughts and its wonderful saving of mental operation. Mathematics may be defined as the economy of counting. There is no problem in the world of mathematics which cannot be solved by direct counting. Then, if you look at another guy, Hugh McCall, an Englishman, who wrote in 1880, Calculus of Equivalent Statement. Here is what you see. Symbolical reasoning may be said to have pretty much the same relation to ordinary reasoning that machine labor has to manual labor. In the case of machine labor, we see some ingeniously contrived arrangement of wheels, levers, etc., producing with speed and facility results which the hands of man, without such aid, could only accomplish slowly and with difficulty. In the case of symbolical reasoning, we find in an analogous manner some regular system of rules and formula, easy to retain in the memory from their general symmetry and interdependence, economizing or superseding the labor of the brain, and enabling any ordinary mind to obtain by simple mechanical processes results which would be beyond the reach of the strongest intellect if left entirely to its own resources. This is what we experience by, with the advent of artificial intelligence, for example. As William Ernest Johnson, more or less at the same time, wrote in the Logical Calculus General Principles, as a material machine is an instrument for economizing the exertion of force, so a symbolic calculus is an instrument for economizing the exertion of intelligence. And employing the same analogy, the more perfect the calculus, the smaller would be the amount of intelligence applied as compared with the result produced. So, in fact, if we look at that, I end up with this kind of let's say, logical consequence. What is computationalism? It's nothing else than arguing up to the last confine of logic of planetary computation. And if I start to have some sort of logical reasoning, almost like a mathematician, then what do we discover? There's no need for articulated discourses. As Frank Varenne says, simulation is neither a discourse nor a language. Discourse is replaced by a planetary white noise. You know, this is what, my own expression. I called what is happening now on the social networks, etc., a planetary white noise. No need for cleverness. It's replaced by computational speed and brute force, or artificial intelligence algorithm. No need for thinking. The more perfect the calculus, the smaller the amount of intelligence needed. So, if there's no need for anything, what is left, ultimately? I would say there's only two things which remains. On one side, for the non-believer, pure conceptual thinking. Science for the non-believers, even if at some point science it's also some sort of belief, and religion. And if the science of calculation ultimately governs, because this is what Babbage was saying, that the science of calculation should ultimately govern, not politicians, so no more politics ever, according to which system of value. And then you end up with that. Because if everything is just a matter of system of values, you cannot say that one is better than another one, because you end up in a loop, because a system of value is just defined according to a system of value. So you find one system of value better than another according to a system of value, and then you don't have any logical argument in addressing a true difference between this. And if you keep in mind this hypothesis by Guy Debord, avant-garde is a dictatorship of reality, then you see that you have two kinds of people nowadays which are addressing the reality. On one side, the one who absolutely want to destroy this new reality and to replace it by a completely different system of value. And on another side, the people who, like most of us, actually are kind of happy with working with a computer, traveling around, being new kinds of nomadic individuals for which life is only a matter of relationship between artificial intelligence or machinic intelligence and the brain. And in fact, I have no answer about that, and I believe that the deep computational, era we are entering in is bringing its new nihilistic scenario in terms of philosophy or in terms of thinking, because we don't have logical arguments anymore to put one system of value on top of the other one. So these are a couple of hypotheses. Thank you.